All right, so here is a lesson on identifying types of functions, linear, exponential, or quadratic from a graph. So sorry about my stand. I didn't know how to get it out of the way, so it's just gonna be chilling over there. Basically, first of all, most of this lesson is gonna be on a graph, how to tell from a graph. But we're gonna first talk about how to identify them from an equation. So it should be pretty easy. But basically, linear functions has an x with no exponent. So, for example, y equals 5x plus 1 is a linear function. Y equals 1/2 x is a linear function. And then we got 2x plus 3y equals 6. So notice this x has no exponent with it. So it's just plain old x. That's how we can tell it's linear. Then for quadratic has an x squared in the equation. So here we have y is equal to 2x squared plus 3x minus 5. That's an example. Another example is y is equal to x squared plus 9. Another example is x squared plus 4y equals 7. And I'm going to add one more because this can be a little tricky, but if we have something that looks like this, okay, we've seen this before. It's actually like something like this factored. So if you see two x's multiplied together, that's the same thing as x squared as well. So don't just look at it real quick and see, oh, there's an x, there's an x. Oh, these x's have no exponent, it's got to be linear. No. Okay, this is still an example of a quadratic equation. It's just in factored form. So be careful because there may be a question on this. I might want to star it. Okay, there might be a question like this on your quiz. So if it looks like this, it's a quadratic. Okay, then the last one we're going to talk about is exponential. Okay, exponential has an x as the exponent. Okay, so we have 3 to the x powered plus 1. Another example would be y equals 5 to the 2x. Notice my x is still in my powers place, or the exponent's place. We have 4x plus y is equal to 13. Okay, so all these are examples of exponential functions. So I just kind of want to go over what they looked like in equation form first. Okay, then the next part, okay, so we're going to talk about linear functions in a graph. Okay, so linear functions are just straight lines. Oops, I need to work on my underlining. Okay, that will go on forever in both directions. Okay, so if a linear function with a positive slope, so if it's going up, so it's going to go up if I'm reading the graph from left to right. And so here's an example of that. So this one's a positive one with a positive slope. Okay, so from left to right, it's going up. It's like traveling up the hill, okay? Then linear functions with a negative slope go down from left to right. So this has, oh, I had to add my E. I added my E over here. Down from left to right. So this has a negative slope. Okay? All right, so that's linear functions. These are two types we're going to look at. One with negative slope, one with positive slope. So just remember that these are what linear functions looks like. Okay, they look like lines. All right, then we're going to move down to exponential functions. So exponential functions are curved lines, okay, that suddenly increase or decrease by a lot. So basically a growth function, okay, it is increasing, or I'd say, yeah, increases. Growth functions increase from left to right. So this is an example of a growth function, all right? Then a decay function will decrease from left to right, so like that, okay? And it's kind of giving you a hint on what the equation looks like for a growth function versus a decay function. We'll go into that a little later, but if you guys remember, like an example of a growth function would be like if I had y is equal to 3 times my b value being greater than 1. So let's just say, I would say, give me a number greater than 1. I'm just going to say 5 to the x. So that'd be an example of a growth function. A decay function would be something that is less than 1. So if I had like 3 to the 1/5. 1/5, my b value is less than 1 or between 0 and 1. Okay, so that would mean that it's a decay function. Okay, so that's all that part's talking about. Now, this is a little fun. I want you to look at this coronavirus cases in Italy versus the U.S. So coronavirus cases in Italy versus this is Italy. And then this is the U.S. Y'all can clearly see that these are exponential. So the thing we're dealing with right now with coronavirus is an exponential function. So y'all can't tell me how to use this in real life. Scientists are using this all the time to track how these diseases are increasing and how they're, like, is U.S. doing a better job than Italy? I think we are. Okay, so just there's a way to compare graphs and to see, exponential graphs like this that are used every day in stuff like this. So let's answer this question together. The coronavirus is an example of what kind of exponential function, okay? It is an example of a growth function, okay, right? Because we're going suddenly up. We're increasing from left to right in that graph. Okay, so the last one we're going to talk about is quadratic functions. Okay, quadratic function is a U-shaped graph, okay? So we've been talking about these for a while now. So what your project was over and everything. So quadratic functions that open up, okay, start up, go down, and then go back up again. So, for example, we start up, we're going down, and we come back up. That's a quadratic function that opens up. I need to add an S here, sorry, typo. Okay, and then same thing, up, down, up. Okay, and then there's one more example down here, up, down, and up, okay? The second one is a quadratic function that opens down. And we've been doing this for a while now, but it starts down, goes up, and then goes back down again. So we'll look at this first one. It starts down, goes up, and goes back down again. This one starts down, up, down, and then down, up, down. So that's it for this lesson. Oh wait, no it's not. We have some practice problems. So what we do is I would ask you guys for these types of questions. Let me zoom out a little bit if I can. Okay. Determine if the following graphs represent an exponential function, linear function, quadratic function, or neither, okay? So I feel like the neither part is where a lot of people are thrown off, but you're not going to be thrown off, okay? Just if it doesn't look like any of the three, the ones we just talked about, guess what it's going to be? It's going to be neither. Okay, so let's talk about this first one. This one would be, and I want you guys to pause the video right now, and I want y'all to try these on your own, and then we're going to go over them in a second. Okay, so hopefully you pause the video and you tried them. All right, so this first one, just check your answers with me, is exponential. This next one's linear, because it's a line. This is exponential because it suddenly goes down. This is actually exponential. Notice it's just like a decay function, but it's just flipped. So this is exponential. Okay, this one's a straight line. So, man, this thing's getting in my way. Okay, so it looks like a line, so it's linear. All right, let's keep going. All right, this one over here, it starts up, goes down, and comes back up again. So this is quadratic. All right, this next one's a line, so it's linear. All right, so look at this one. It's kind of just looks like a wave. So have we talked about one that looks like that? No, so this is neither. And this last one is actually exponential. So it's actually, if you flip this, it looks like it's going up. So it's just flipped upside down, so it's exponential. So don't get tricked by, because just like with quadratics, how we can flip this and it still be a quadratic, that's the same with exponentials, okay? They can be flipped upside down. All right, so let's try these. You should have paused the video and done these as well. If you haven't, go ahead and do that. Try them, and then we're going to go over them. So this first one is linear. Second one, exponential, because the x is in my exponents. Okay, y is equal to 2. So you may not remember this, but that's just a straight line up and down, so that is linear. All right. Then this has an exponent, or x is an exponent, so it's exponential. Okay. This is an x in the exponent, so exponential again. And then the last one, we have an x squared. So since we have an x squared right here, we know this is quadratic. All right, and that's it. Hope you guys got it, and go ahead and you can try your IXL CC1. All right, see y'all soon.